Hello students, welcome to IMS Academy. The second session I am studying in gate score booster, but I am going to do the few more number of the problems from the analog circuits. Try to understand. You can also practice along with me. Understand now. When I give any problem here, just wait, I'll start. Yes. And before starting the session on analog circuits, I would like to give you some information regarding the IMS Academy. You join our Telegram channel. The students wants to join in the Telegram channel, they can do it now. So what are the advantages if the student joins in Telegram channel? What are the schedules of the free YouTube lectures you will receive? Lecture PDFs and also important updates related to the seminars and webinars, PSU and other government job notifications, expert session on important topics, daily quiz. These are all possible if the student joins in Telegram channel. Next one, the students who wants to take admission in GATE 2025 and 26, they must know the program futures. 800 plus hours of live classes with live interaction, theory book, exercise books, and 30 plus years of the GATE question banks with video solutions available. They will give 12 personalized one-to-one mentorship sessions, 130 plus online tests with the video solutions of the mock test, and many more. The students wants to get any information to get the admission in IMS GATE Academy, they can call to this number. Understand now? Yes, we can enter with the subject now. Yes, this is the first problem. This is the first problem from the analog circuits here, the second session. Anybody can do this question without my help? Any student can do this question without my help. Initially, I wish to give in the hands of the students. They are giving answer very good. Otherwise, I will do no problem. Understand? What is given the problem? If voltage drop across the diode is 0.7 voltage, then which statement is true for this circuit? And 4 options are given. Option A, current I equal to 9.5 milliamperes. Option B, current I2 equal to 9.5 milliamperes. And current I1 equal to 9.65 milliamperes and I2 equal to 0 amperes. Only one diode, D1 is on and D2 is off. Like that, 4 options are given. But this question is a MSQ question. I want to know how many students can do this question. Can you do it? Anybody can do this? Yes, I will do. Please watch. Here the 2 diodes are given here. The currents passing through the each diode also given. The supply current is nothing but the I and divided as a I1 and I2 here given like this. These 2 diodes are ideal or non-ideal. At first you check it from the given problem. They are not ideal. Why they are not ideal? It is given the drop across each diode is given 0.7 voltage there. On watching that 0.7 voltage, you can come to the conclusion those 2 are non-ideal diodes. Those 2 are non-ideal diodes only. And how we can measure the current I, I1 and I2. So I, I1 and I2 you can determine at first. All the currents we can find. If the currents I1 and I2 are positive values, you think it's so. Suppose you got those 2 currents passing through the diodes are positive. We can say those 2 diodes are on state only. If any one of the current I1 or I2 you got negative, you think it's so. The diode is off. the current to the diode will not be negative, that will be always positive value now. So, we should make an assumption initially the diodes are on state. That assumption you make it now and start doing. Understand? But don't short circuit any diode, because they were all not diodes. What now? Ideal diodes. They were all non-ideal diodes. Drop across each diode 0.7 voltage is given. How we can do? This question you please watch. I want to do solution here now. But here I made an assumption those two diodes are on. I said already. In this case, this node voltage I here selected as a VA. Node voltage is taken as a VA. What is that voltage? What voltage you can have at that particular point? The voltage across this diode D1 is nothing but the VA only now. Voltage across this VA is nothing but voltage across this diode D1 is nothing but the VA only now. So, voltage drop across this diode is a 0.7, same voltage you can find. Otherwise, you can draw the equivalent circuit like this. Here given 20 volts battery here, I will connect. I will connect here 20 volts battery. This is with 20 volts battery. And 2 kilo ohm resistor is given here. This is 2K resistor. These two diodes are on, I said already now. If it is on, we can replace this with a voltage source. When the diode is on, that can be replaced with the voltage only. What voltage? Voltage across D1 is nothing but 0.7 voltage. So, just I replace with battery like this now. Voltage drop across each diode is 0.7 voltage. And one more diode we got here now. Here I got the resistor 30 ohms is given. The resistor of resistance is given 30 ohms. One more diode is given plus minus. The voltage across this is nothing but 0.7 voltage, you know very well. This current is given I, this current is I1, this current is I2. But I want to know these two diodes are on or off, or any one of the diode is on, we need to identify. What is this voltage? This node voltage is nothing but same 0.7. I can put 0.7 voltage. 0.7 voltage. Now, I wish to apply the nodal analysis here now. This current plus, this current plus, this current equal to 0. Just nodal I applied. What this current I want to measure now. This current equal to what directly? Or directly you can get now. You can get, I think now. This nodal also not required. Still easy. Very directly you can get, I think now. Still easily you can get now. Nodal also not required here now. Still easy way you can get now. I is nothing but 20 minus 0.7 by 2K. Directly Ohm's law you can apply. Directly you can use Ohm's law. I wish to find I1 here. I here. 20 minus 0.7. 0.7 divided by how much? 2K here. This 2K. What is I? 20 minus 0.7 is nothing but 19.3 divided by 2K I can write here now. What is I? We can see. So, how many times we can divide 2 nines? 18.26 12 2 5s 9.65 I am getting here now. 9.65 milliamperes I can get now. Milliamperes of current is possible. How much you are correct right now? 2 9s 18 1 3 2 6 12 2 5 9.65 milliamperes I am getting here now. That is I. What about this I1? I1 we can see. What about I2? I2 is directly 0 only. 0.7 minus 0.7 divided by 30 ohms. That becomes 0 amperes only. 0 ampere or negative value, if you got, the diode is off only. So I2 is off, D2 is off, I can write I2 is 0 means D2 is off, it is not on, this is in off state only, this is in off state I can write, this is in off state only we can say. But if it is in off state, I1 will be what? Same current. I1 equal to, we know very well. What minus what? I1 is nothing but I minus I2 only. I minus I2. I is nothing but 9.65 milliamperes. Minus I2 is a 0. It becomes 9.65 milliamperes only now. So I1 is, D1 is on only possible. This is on state only possible. So here the point what you have to understand, the diode D2 is off state only here now, I2 is 0. So whatever the current of I passes across 2K, same current will pass across D1 only now. Finally, D1 is on and D2 is off only possible. I can write clearly, D1 is on and D2 is off. This is the statement we can write now. But the what those options are correct? This is a MSQ question only now. The current I equal to 9.5 milliamperes. Current I equal to 9.5. I is not 9.5 milliamperes, 9.65. This is wrong. Option A. Option B, current I2 is a 9.5 milliamperes. No, that's 0 only we got. Option C, current I1 is 9.65. Yes, we are getting milliamperes. And I2 is 0. So option C is correct. Option C is correct here now. Directly you can put. Option C is correct here now. This option is correct only now. What about option D? Only one diode D1 is on and D2 is off. That is also correct. This is also correct only we can say. So here I can write solution option C and D only correct only now. Solution is B, C comma D only now. Is C and D. C and D correct only now. C and D correct only now. Two are correct now. C and D are correct I can say now. This way we can do this question. I hope you followed. It's not complicated question. And one more question we can do now. This is the next question. Yes, to start doing this question, I will wait for some time. You start doing this question. I wish to give this problem in your hand. You please tackle this question. This is the question from the negative feedback amplifiers only now. This is from the feedback amplifiers. I will see how many students can do this question. What is given problem first of all? An amplifier with an initial open loop gain of 400. Open loop gain is given 400. Is used as a negative feedback amplifier. A negative feedback is applied. The feedback factor is 0.05. You know very well, feedback factor is nothing but the beta. Beta is given 0.05. If gain of the amplifier changes by 10%, gain of the amplifier changes means percentage it is given, dA by A into 100 is given 10. Due to temperature, then the closed loop gain will change approximately by, after feedback, what now the closed loop gain is nothing but the AF only possible. The change of this closed loop gain is asking now DAF by AF into 100 equal to how much is asking in the problem. Yes, you can do this question easily now. Can you tackle this question? Anybody? Start doing this question. Yes, I will do clearly. I will give now. An amplifier with an open loop gain is given. Open loop gain is nothing but A. Open loop gain is denoted by letter capital A. A is given as 400 here. This is given as a 400. This is given 400. The feedback factor is 0.05. It is given beta value. 0.05 is given here. Feedback factor is given. If the gain of amplifier changes by 10% due to temperature, dA by A into 100 is given. What percentage is given? 10%. 10 I can put here now. And also is asking the closed loop gain will change approximately by, closed loop gain means DAF by AF into 100 equal to how much is asking here. After finding that value, DAF by AF into 100, if you want to get means first you need to create the formula. The formula comes easily, you get diagonal now. How we can get DAF by AF into 100 here? We know very well, we know that, directly you can write, we know that the feedback gain equal to AF is nothing but A by 1 plus A beta. A by 1 plus A beta is generally used for feedback gain. But what I did here now, in order to get DAF by AF into 100, I want to differentiate on both sides. Just to differentiate on both sides. The AF changes with the change of A. When the A is changing, AF also changes. What they are said to be variable means AF is a variable and A also variable. Differentiate on both sides. Differentiate on both sides. Just I am asking to differentiate on both sides with respect to, I didn't specify, just to differentiate only now. So, d of AF, derivative of this AF equal to derivative of this function, A by 1 plus A beta, I can write directly. But now thereby required differentiation. DAF I have taken as is. DAF is taken here as is. A in the numerator and A in the denominator now. I can apply U by V formula. V into derivative of A. V is nothing but 1 plus A beta. 1 plus A beta into derivative of A is nothing but dA I can write. Derivative of A can be taken as a dA minus A into derivative of A into derivative of 1 plus A beta. 1 derivative 0. A beta means beta is constant and derivative of A dA whole divided by V square, U by V formula, V into derivative of U minus U into derivative of V whole divided by V square, 1 plus A beta whole square I can write. In such a way we can form. Just I want to expand this. If I expand it, I can get DAF equal to 1 into dA dA plus A beta into dA I can get minus A beta into dA I can get whole divided by 1 plus A beta whole square I can write. I can cancel A beta dA, I cancel directly. I cancel now. And I got DAF that equal to dA by 1 plus A beta whole square I am getting here now. DAF equal to dA by 1 plus A beta whole square. Just I want to simplify this again. How we can simplify this? You please watch. We got DAF. DAF equal to what we are getting here now? dA by 1 plus A beta whole square. That I want to write 1 plus A beta into 1 plus A beta. I can write 1 plus A beta whole square is nothing but 1 plus A beta into 1 plus A beta. We know very well the feedback gain equal to already given A by 1 plus A beta given already given. Here I want to take 1 by 1 plus A beta. This term I want to take one side. That value how much? 1 by 1 plus A beta equal to how much U was? 1 by 1 plus A beta equal to how much? AF by A. AF by A is possible. But this I want to substitute this 1 by 1 plus A beta, this value I will put now. This 1 plus A beta I want to keep it up as it is now. DAF equal to, I can write 1 by 1 plus A beta is nothing but AF by A into what is still left? DA by 1 plus A beta is left. Variables, separables I want to use. DAF by AF, DAF by AF, that equal to 1 by 1 plus A beta, 1 by 1 plus A beta into DA I can get. Variables, separables, separate. I want to multiply on both sides by 100. DAF by AF into 100, that equal to 1 by DA by, here what is now? DA by A is there now, DA by A also is there now. So 1 by 1 plus A beta into DA by A into 100. Then you can substitute the values. So this is the formula you must remember. No need to derive, just understanding purpose I did that source now. If you know this formula, directly you can apply. It's not a big task. Is asking in the problem DAF by AF into 100 equal to how much is asking in the problem. That we can determine. Change of this feedback gain is required. In a problem it is given 1 by 1 plus A, open loop gain is given A. A is a 400 here. A equal to 400 is given. And what about the beta? Beta value is given as a 0.05. 0.05 into DA by A into 100 also given in the problem. DA by A into 100 is nothing but 10, you know very well, into 10. Use calculator and give its value. What value it comes? Anybody can give answer for this? Just use calculator and give answer. But I want to know what answer you are getting. Any student can do this? You do the calculation and give answer. I am waiting for your answer. What value it comes? Approximately it comes 0.5% only now. 4 into 5, use it now, but around 0.5% it is possible. Approximately it comes, whatever the value it comes to right now. Mostly it comes 0.5%, I hope. 5%. Approximately 0.49 or 48 something it came in 0.5, approximately I have taken now. Understand now? That much value is possible. Understand now? But if it is a slight change, means 0.4 something it came in, so okay, you put it, no problem. Understand? This is answer. Next question I want to give. Yes, this is one more question. You can try this question without my help. You please try this problem without my help. But I want to wait for some time. What's the value possible now? What answer you can get from this? Any student can do this question without my help? This is V naught, here not given. This is V naught. V naught is nothing but this value. This is V naught. Can I get answer for this question? Anybody can get answer for this question? In the problem it is given Zener diode, transistor and operational amplifier. But this network is nothing but regulator circuit. It is a voltage regulation purpose this circuit is used. But what V naught I can get if I use these circuits, that's more important. What is asked clearly was find V naught of op amp where VBE of BJT is 0.7 voltage is given here now. This voltage 0.7 volts, no problem. Is asking what is V naught. How to tackle this question? It's a very simple question. In this problem, I can say this voltage we know very well. This node voltage you know very well. This voltage is nothing but voltage across this Zener diode. Voltage across this Zener is nothing but this node voltage one. What is that voltage? 4.7 voltage here given. This node voltage is nothing but 4.7 voltage. So this 4.7 voltage is nothing but the V plus value. This is V plus one. V plus equal to this much. Catch my point. This voltage is a V plus, positive terminal. This is V minus this value, V minus. This V minus equal to what potential is possible? V plus and V minus are same possible here, you know very well. The last session I explained. If these two potentials are equal, V plus equal to V minus means same 4.7 voltage will be maintained here also. Same 4.7 voltage will be maintained here also. So this 4.7 voltage can also be said drop across this 4.7 K. The voltage drop across this 4.7 K is nothing but same 4.7 only. V minus is nothing but drop across this 4.7 K. Followed or not, I am repeating again. V plus is nothing but voltage across this Zener only. Yes, something very good. Akansha Sharma 3.3, very good. You are very fast. 3.3 is not correct, I think. Once again, you check. Answer is not correct, I think. Okay, I will see the now. Anyhow, this voltage we got now. This voltage also same V naught only, no doubts. I can apply, but when the V naught, if you got, the current is going to flow in this particular direction. Current is passing in this particular direction. Yes, Akansha Sharma, hello, good evening, sir. Yes, good evening, good evening, good evening. The current is going to flow this side. Can you find any current across this negative terminal side? It doesn't flow any current. Why this current is not passing this side means input impedance of operational amplifier is infinite. At the time, it doesn't allow any current in this particular direction. The same current across two resistors are passing means you can apply voltage divider formula directly. Voltage division formula is applicable. What is voltage division formula here? I can write like this now. Suppose the resistor is nothing but the R1 here, I am saying now. This is nothing but R1 here, the resistor is nothing but the R2. I can write like this now, solution. Applying voltage division formula. Voltage division formula I want to use. What is voltage division formula here now? V minus voltage across 4.7 K is nothing but V minus equal to supply voltage V naught into what resistor? R2 by R1 plus R2. The formula is applicable from the voltage divider formula. There you can substitute directly. V minus is nothing but how much here? V minus 4.7, no doubt. The V naught is required. R2 is nothing but 4.7 K. K cancel here now. The 4 plus 3, 7, 7, 8 is possible here now. This is 8. V naught into 4.7 by 3.3 plus 4.7, it becomes 8. Yes, 8 volts, exactly correct. No, correct. On both sides, I can cancel 4.7, 4.7. Finally, V naught is nothing but 8 volts here possible. This is the solution for this question. Followed this? That way we can tackle this question. I hope you followed. Approximately 8 voltage is possible. Understand my point now? Okay then. Next, I want to apply next question here now. Now you please try this question. I will give in your hand again. This is one more question. You start doing this question, but I want to wait. You please try this question. Enhancement MOSFET. Please try this question without my help. Initial work is required from your side. Initial work is required from your side, I say. Anybody? Any chance or no chance to get answer? Yes, you please watch what is given in the problem. For the N channel E MOSFET, that means enhancement MOSFET used in the circuit, Vt equal to 1 voltage, they are given threshold voltage is given 1 volt. Mu n COX W by L equal to 0.3 milliamperes per square volts. Find V naught. Is asking to find the V naught for this given MOSFET. But how we can determine that value? You should understand certain points clearly. It is an enhancement MOSFET. This is the drain. So this side current is nothing but the drain current ID I can put. This side is going to flow drain current. Current passing through this side is a drain current, I can say. What is this node voltage? If I ask anybody, can say same V naught sir. Same V naught is possible. Drain current and source current same, no doubt. The gate current is approximately 0. Why sir? The input impedance of this MOSFET is very high. It doesn't allow. The current is passing. There is a negligible amount of the current only now. Here the point what you have to remember is, my question is, can you say what drain current is passing in the network? What drain current is passing in the network, I ask. Drain current means current across 2K. 5 minus V naught by 2K I can write. I say the drain current is calculated by 5 minus V naught divided by 2K I can write directly. This I want to take it as equation number 1. 5 minus V naught by 2K, just Ohm's law I apply. But I made an assumption that the MOSFET is in saturation condition. I made an assumption. If it is in saturation, I made an assumption MOSFET is in saturation. If it is in saturation, drain current you can calculate by using this formula. drain current equal to what formula they will apply generally? Mu n COX, mu n into COX by 2 into W by L into VGS minus VT whole square they will apply. This formula is generally applied. We are going to use this formula generally now. Drain current is possible now. Yes, all the values are given there. You substitute and find V naught now. What V naught you can get? You please find it. You please find this now. Formula I gave it now. You please try this question without my help now. Every formula I gave it now. You measure V naught now. I hope you can give V naught. What V naught you can get from this? What value possible? But I want V naught value. Anybody? But gate volt VGS is nothing but, still if you want to know, I will write VGS is nothing but, sir, VGS is unknown, sir, how I can find, sir? One more doubt is going to arise to the students. VGS is nothing but VG minus VS, no doubt. The source voltage is nothing but this voltage, 0 voltage only. VS equal to 0 voltage only possible. VS is a 0 voltage only. What about this VG, sir? Gate voltage, how much, sir? This gate potential, how much, sir? Suppose anybody asks. This Vs is a 0 voltage only. The current passing through the what now? This gate is approximately equal to 0 only, I said. Why, sir? Input impedance of this MOSFET is very high. The gate current is approximately 0. The gate current is 0 means if this node voltage is a V naught means same voltage you can find VG also V naught only possible. Gate potential can be same V naught. There is no drop across 10 mega ohms. Reason is what? There is no current this side, approximately 0. The drop across this 10 mega ohm is a 0 only. Finally, I can get same V naught only now. Now I can write here VGS can be written as a, how I can write this VGS? VG equal to V naught, Vs is a 0. Finally, I am getting V naught only. Now I can write this drain current like this. ID equal to mu n COX. First I will write these values. Mu n COX by 2 into W by L. VGS equal to how much? V naught itself. VGS equal to V naught. This is VT whole square. This I want to take it as equation number 2. Equation 1 and equation 2 are same. This is ID, this is also ID only. I can equate both. If I equated both, I can measure V naught value directly. Yes, you do it now. You can do it now. I can do like this now. But equation 1 equal to, I want to take equation number 2, I can write. This ID can be taken, this mu n COX W by L 0.3 milliamperes. 0.3 milli. But divided by 1, 2 is there, that I will put as it is. Into V naught minus VT. VT is nothing but 1 volt is given, whole square. Followed or not? Mu n COX W by L is a 0.3 milli by 2 is there, that I will put here now. And still anybody getting answer? I have taken this now. This side, equation 1, this I substituted now. That equal to 5 minus V naught by 2K. That equal to 2K only possible. Equation 1 equal to equation 2 I equated. Just expand and find what is V naught. Just expand and find V naught. You must expand. One quadratic equation is going to form. If you are expanding this, you will get one quadratic equation. So minus b plus r minus, if you applied, you will get the 2 roots. Out of those 2 roots, one will be positive, one will be negative will come now. that positive value will be taken as a V naught value only. Positive value is a must. That means if you are expanding this, mostly the equation comes like this. I will give understanding purpose. I will give for your understanding purpose. If you expanded this equation, you will get 0.3 V naught square, 0.3 V naught square plus 0.4 V naught, 0.4 V naught minus 4.7, that equal to 0 positives. One quadratic equation is going to form like this. Minus b plus r minus under root of b square minus 4. If apply, you can formula, quadratic formula, you know. You calculate V naught, one positive, one negative, you will get now. You must take positive value only. Mostly it comes like this now, minus 0.4 plus or minus 2.41 by this value, it comes like this. 0.4 by 2.41 by 0.6 it comes. At the time V naught is to be taken positive, I said. Positive means what must be taken now? Minus 0.4 plus 2.41 by 0.6 to take it. It comes as 3.35 volts, it comes mostly. 3.35 volts. This is the solution for this question. V naught equal to 3.35. But it takes some time to expand and everything, you know. Understand now. But you must do only. That way we can tackle this question. Any student having any doubt regarding this problem? Did you understand this question? Followed this? And I want to give one more question. You please try. You please try this question. One more. It's a one more good question. Start doing this question. You can start doing this question. You can do this. You can do this question. What is it asking in the problem? Find V naught. Is asking to find this V naught value. V naught is required for the given circuit. I didn't give any options, just for practice I gave like this. Now find V naught for the given problem. Anybody can do this question? How to find V naught? What way you will do this question? You start doing this question. Yes, I will do. Please watch. You will understand clearly. Is asking to find V naught. How we can find this V naught value? This voltage is to be taken as a V minus, no doubt. This node voltage, even this voltage or this voltage or this voltage, all are same. We can combine these 2 points. Single point only it is finally. That is nothing but V plus. V plus and V minus are same. V plus and V minus are equal, exact word, equal both. But these two are equal means I wish to put this potential as a V, for example. Even this potential also I can put V, V or Vx or something, any name you can give. These two potentials are same only now. Without knowing voltage V, I cannot determine V naught value. Without determining V value, we cannot get V naught directly now. But what way we can find this V? At the top you watch, it is a negative feedback is connected like this only now. Here given. In this case, what I will do is, here this current equal to this side, it is going to flow current of I, for example. Suppose this current is I. Just wait. If this current is I, this current is nothing but the feedback current I have taken for example. This is a feedback network only here. What current is passing across 1K, the same current will pass across this 1K. If it is a I, it is divided as IF. IF and I are same, I say. The students may ask, sir, how can you say some current is passing through the op-amp, sir? No, it doesn't flow any current. But mostly we will give ideal op-amp. I didn't write all these now. Ideal op-amp this now. For ideal op-amp, input impedance of operational amplifier is infinity, you know very well. If input impedance is very high, that is a infinity, current is approximately 0 only. That is why this current I equal to IF possible. It doesn't flow any current through the negative terminal, I can say here now. I equal to IF only possible now. I say, what I said, the I and IF are same, I am saying here now. I and IF are same, I said. Otherwise directly nodal applicable, no problem. What is I? Phi minus V by 1K. According to Ohm's law, I is nothing but phi minus V divided by 1K. I have written that equal to IF. IF means current across this 1K. Current across 1K is nothing but V minus V naught by 1K. I can write. I want to put IF is nothing but V minus V naught divided by 1K. I can write. My aim is to find what is V at first. Initially, I want to find V. Once I know V, I can determine V naught. So, in this case, 1K here cancel. I will get phi minus V, that equal to V minus V naught I can get. You find what is V here. V, if you brought this side, V plus V, 2V is possible. 2V equal to 5 plus V naught is possible. I can say V plus V, 2V, that equal to what? 5 plus V naught is possible. Thereby calculated V value. 5 plus V naught divided by what I can get? 2 I can get. This is V value. We can put one side. Finally, we are getting V in terms of V naught only. V in terms of V naught. That you put it one side, that equation. Now, please watch, same voltage here maintained. Here I want to apply the nodal analysis. This point and this point is same. We can combine as a single point only now. If I apply the nodal analysis, the current directions I can put like the away from the node required. This current plus this point and this point is same. This plus this also same voltage V only. Away from the node, this current equal to 0 only. Summation of all these currents equal to 0. Directly you can put here now. How I can form an equation here? Current across this 1K is nothing but V by 1K, because this side 0, V minus 0 by 1K. I can write directly V by 1K. I am getting this side current. What about this current? V by 500 ohm. That means V minus 0 by 500. I can write V by 500. I can write directly V by 500. I can write. One more equation. And one more equation I can form top. Top means V minus V naught. V minus V naught divide V minus V naught divided by 1K. I can write divided by 1K. This is equal to 0 is possible. This is equal to 0. Summation of all the currents equal to 0. But our aim is to find V naught. Main aim is a V naught only. Wherever you got the V, there you can put what directly? 15 plus V naught by 2 only now. I say here the V I want to take common. If I have taken V in common, I will get 1 by 1K The V is taken here now 1 by 500 I can put here now, this is a 1K. V if it is taken common here now 1 by 1K I can get here now. And this side what I can get V naught by 1K I can get this side. V naught by 1K. Such a way equation is formed. Now the V value I can substitute now. V is nothing but 5 plus V naught. 5 plus V naught divided by 5 plus V naught divided by 2 given 2 into these values 1 by 1K plus 1 by 500 here plus 1 by 1K here, that equal to V naught by 1K only. Now you can simplify this equation. On simplification you can get V naught value. Just to simplify, use calculator and simplify. And if you simplify it, mostly V naught comes as, I will give the V naught value. That value will be what V naught is possible, I will give. Minus 10 voltage here possible. V naught equal to minus 10 voltage possible on simplification. But this simplification I will not do the now, understand now, just using calculator one now. If you are using the calculator, you can get directly V naught equal to minus 10 voltage. It is not a complicated task, understand now. This is the answer for this question. I hope you follow. If there is any doubt, you can arise your doubts. I am ready to clarify, understand now. And I wish to give one more question. This is one more problem. You start doing this question. You can start doing this question without my help. You try this question. I will wait for some time. Any student can do. What answer you can get from this question? Any idea? No idea? You tell me. If you have any idea, I will wait for some time. No ideas are yes, I will explain, no problem. Any student can respond. Do you have any idea about this problem or not? Respond. Tell me, Akansha Sharma, possible or not possible? If there is no idea, I will do no problem. Any idea or no idea? Message it. Yes, I will do this question, please watch. I will do this problem. But anybody can say what is the name of this network? On watching this network, you can identify what its name. What is the name of this circuit? Anybody? Anybody can respond. What is the name of this network? This is nothing but Darlington amplifier, we can say. The given network is a Darlington amplifier. This is said to be Darlington amplifier circuit. This is said to be Darlington amplifier only. The name given for this network is a Darlington amplifier. Sir, what is the purpose of this Darlington amplifier? Some information I will give. Sometimes asking certain questions from the Darlington amplifier. Its purpose is nothing but to increase the current gain. Whenever you want to get the more current gain, you think it's so, you must use Darlington amplifier. Immediately students may have a doubt. Sir, common collector amplifier is for increasing the current gain only now. Common collector amplifier can increase current gain and it can decrease the voltage gain. Then why do you use Darlington amplifier? Yes, what you said is true only here now. Common collector can give the current gain. A single common collector cannot give the required current gain. With a single stage of amplifier, we cannot get only now. Understand now? But if you are cascading the two common collectors, for example, what's going to happen? Current gain is going to increase more only, we can say. If two common collectors are cascaded, the current gain is going to increase only now. You know very well that point. But here the Darlington amplifier, the definition will be given like defined like this only now. How it is given? Darlington amplifier, what now? The cascading of two common collectors. Catch my point. Cascading of two common collectors is said to be a Darlington amplifier only. Cascading of two common collector is a Darlington amplifier, means practically what they will do, the emitter can have one emitter resistor also. One RE resistor RE will be connected in the Darlington amplifier. And output is taken across this V0. There is no RC here. They will give this voltage will be taken as a VCC value. This is a part of the network, partial network only given here now. The full network is not given here now. So, if it is given the supply voltage and base voltage, here the emitter resistance is given, output is taken across this RE for example. Output is taken across RE means we can say the name of that network is nothing but emitter follower, that we can call it as a emitter follower. But you should not say here now emitter is connected here sir, there is a common emitter configuration sir. No, we can't say like this. Emitter resistance is connected, output is taken across the emitter resistance, there is no RC. At the time we are going to call this as a emitter follower. Emitter follower under AC analysis can act as a what? Common collector only. Point you catch it now. The emitter follower under AC analysis can act as a common collector only. Finally, Darlington amplifier here is a common collector only now here now. There is a cascading of two common collectors can give more current gain. Finally, we can say it can give the more current gain now. But this common collector has got one more property here now. Input impedance is always very high input impedance it can have, and input impedance is very high, output impedance will be very low possible. But how we can determine what he is asking in the problem? First you watch it now. Each transistor in Darlington pair as shown in the figure has HFE equal to 100. HFE means what? Forward current gain. The forward current gain can also be written as a what? Beta. This HFE can also be written as a beta value also. Is not a mistake. HFE means forward current gain 100. That can also be taken as a beta value only. This is the beta value for what? HFE equal to 100 is for what now? But HFE is nothing but the one transistor gain. One transistor gain is given. Overall HFE of the composite transistor, overall gain is asking now. Overall HFE of the composite transistor, neglecting leakage current is, catch my point. Beta value possible for one of the transistor, for the second transistor beta possible. In this amplifier circuits, what total beta is available? Total gain is how much? What current, what gain? Current gain how much is asking. You can understand clearly here now. But here the current which is passing this side, I wish to take it as a, this current I wish to take it as a some IX I have taken here now. This current is IX I have taken here now. This is IX I have taken. Otherwise total current, collector current it becomes now. IX, this current is nothing but IC1 I have taken here now. This current is nothing but IC2 I have taken here now. Otherwise this is a total collector current. IX or otherwise IC, total IC we can assume for example. Total IC is nothing but IC1 plus IC2 only now. and I wish to take this current is nothing but the base current of the first transistor. IB I have taken here now, for example. Base current I have taken IB. Try to understand clearly. This is the base current. This current can be said in two different ways. Emitter current of the first transistor I can write. This can be said as a emitter current of the first transistor. IE1 I can write. And also I can say this current is nothing but the base current of the second transistor also. This emitter current of the first stage can be the base current of the second transistor. I can write IE1 equal to IB2 also. I can write IE1 equal to IB1 I can write here now. Base current is possible now. But overall what now? The current gain is nothing but IC by beta. Generally we know for a single transistor when you want to find means IC1 by IB1 generally you write for the beta 1. Second, one more transistor you got means IC2 by beta 2, IB2 you will write directly. Overall gain I want now. Overall gain means total collector current divided by the total base current. That ratio can be taken as a overall current gain only. The overall current gain I can get from the overall collector current divided by overall base current only. Then I can get the overall HFE of the composite transistor only here now. That point very important here. Now one more point you try to understand. You can understand clearly here now. But in this problem I can write IC is nothing but IC1 plus IC2 I can write. My aim is to find the ratio of IC by IB. IC equal to IC1 plus ICT you know very well. But I ask, can you find what is IC1 here? What is IC1 I ask. IC1 I can write as a what? Beta into beta times, beta means this is a beta value, beta times of base current, beta into IB you know very well. For IC1 means beta into IB1 I can write here now. IC1 is written as a beta into IB1. What about IC2 sir? IC2 how we can write? Beta times of, catch my point, beta times of base current of the second transistor. Beta times of IB2 I can write. Beta times of IB2 is allowed, it's not a mistake. In this case, you catch IE1 equal to IB2 only now. IB2 is there, that IB2 is also equal to IE1, we know very well. Base current of the second transistor is equal to emitter current of the first transistor. Emitter current of the first transistor can also be calculated by what formula? 1 plus beta times of IE1 is nothing but 1 plus beta times of this IB. 1 plus beta times of base current of the first transistor you know very well. 1 plus beta times of IB1 we can write. Now I want to substitute this IB2 here. I can write as a beta into IB1. IB1 means IB only. IB1 equal to IB only. I can write directly here IB best. IC1 equal to beta into IB only now. I can write directly beta into IB plus beta into IB2. I want to write IB1 is nothing but IB only here now. That point clearly I want to give. Beta into IB plus beta into IB2. IB2 is nothing but 1 plus beta times of IB1. IB1 is nothing but IB I can write. But overall HFE, overall HFE, I want to write clearly. Overall HFE given, this value required. I want, that is nothing but IC by IB I said. Total collector current divided by base current, IB only. That ratio, if IB is taken common, still what is left? beta plus beta into 1 plus beta I am getting here now. By using this formula, you can determine the required overall current gain. Just substitute beta value, you will get. The problem, it is given beta equal to 100. I can write beta is nothing but 100 here, plus this beta is nothing but the 100 here. 1 plus beta, 1 plus 100 I can write. Use calculator. What value it comes, you please tell me. Anybody can give answer for this question? What answer you can get for this question? You please tell me. If anybody is getting answer, you please give it. Its value will be 10,200 is possible. Its value is, because this value is nothing but the 100, you no doubt. 100 plus 1, 101. 101 into 100 if you multiplied, 10,100 is possible. 10,100 is possible. This is nothing but 10,200 is 100 plus 100, 200 is possible. 10,200 overall gain is 10,000. 10,200 means which option is correct? Option D is correct in this problem only. Option D is correct. I can take directly. Option D is here correct. This option is correct. In that way, we can tackle this question. If anybody having any doubt, they can arise. They can arise if there is any doubt in this particular problem. Shall I go to the next question then? Yes, I will give one more question. Yes, you please try this question without my help. I will wait for some time. How many students will do this question? I will see. Any student can do this question. Is a part of network is given, part of the network, but don't say, sir, there is a 2 milliamperes hanging in the air, sir. How it can hang? No, it is a partially given this network. The full network is not given. Understand? Please try this question and find which option is correct here. It's a good question. What is given here? All transistors as shown in figure are identical. Mostly in the current mirror biasing circuits used, all transistors identical. This is also current mirror biasing only. Here given what now, all transistors are identical here. Then the collector current for Q1 and Q2 are, is asking collector current of transistor Q1 and transistor Q2. These two currents is asking now. Can you find it? Anybody can do this question? But I want to wait for some time. If anybody gives answer, very happy. Just you try. If you are getting answer, very happy I am saying now. Yes, I will explain now. You will understand clearly. But in this question, you please watch. This and this is a current mirror, I mean this is also current mirror only here now. This current I wish to take it as a IC1 collector current of the first transistor. This current I will take it as a, this is 2 milliamperes we got, this current is some current, IX. I will put now. This current is nothing but a IC1, I will put here now. Collector current of the first transistor. I want to denote IC1. That means this 2 milliamperes is divided here now. One is a IC1, some other current IX. After reaching to this junction, this IX is divided here now. This current is divided. In how many parts it is divided? In 3 parts. One is this current, second one is this, third one is this. This current will flow this side, finally it reaches to the what? No, base side. This is nothing but the base current of the third transistor only. Follow the point clearly. Base currents of the 3 transistors will be same possible or different currents are going to flow. I am denoting first symbols, then you identify. This current is the base current of the first transistor I have taken. This current I want to take it as a base current of the second transistor, base current of the third transistor. But in the problem it is given clearly all the transistors are identical. All the transistors are identical. And also beta value 250 is given here now. Beta value 250 means a beta value of the first transistor or second transistor or third transistor is with same only, I can say. It won't be differed. It won't be differed only. That is going to maintain same. That's going to maintain same only now. Understand my point now. These 3 currents are same only now. That means that the beta values are same. If beta values are same, transistors are same, base currents are going to remain same only now. Base currents are going to remain same only now. That means base current of this, base current of this, base current of this will be same. I say the point what I wish to give here is, in this particular question, IB1 equal to base current of the first transistor equal to base current of the second transistor equal to base current of the third transistor equal to IB only. Each value I want to take it as a IB value only. IB1 equal to IB, IB2 equal to IB, IB3 equal to IB1. Otherwise you can write IB1 equal to IB2 equal to, all are equal only now. Understand now? Otherwise all are equal to IB only now. Understand now? Okay, otherwise IB you can use now. Otherwise this is equal to IB1 equal to IB2 equal to IB3, no doubt. Finally this IB2 equal to IB1 I can write, no problem. This I can write as IB, this is IB1 means IB2 can also be written as IB1. IB3 can also be taken as IB1 only now. Because transistors are same, beta values same, at the time base currents are same only now. But these are all the currents of collector currents of the transistors. This is nothing but the IC1, this current is nothing but the IC2, this current is to be taken as a IC3 only now. We can find all these 3 currents same or different here. IC1, IC2 and IC3 are same or different currents are going to flow. Beta values are same, base currents are same. IC equal to beta into IB only. What is IC1 if I ask beta into IB1? What is IC2? I ask beta into IB2. IB2 equal to IB1, beta into IB1. What about IC3? Beta into IB1 only now. So IC1, IC2, IC3 are same only here. So I can write clearly here. I wish to write this, that point I want to give here now. Here IC1 equal to, the point very important, IC2 equal to IC3 only possible. All these 3 currents are same possible here now. Currents are possible. So is asking Q1 and Q2 only now. Here option means without doing the work, that point whenever you find IC1 equal to IC2 equal to IC3 means directly answer you can give. No need to do the work also now. But I will do anyhow how to solve the question now. But very directly you can write this question. Here the options are given 1.97 milliamperes, 1.97 milliamperes for collector currents for Q1 and Q2. Both currents are same. IC1 equal to IC2. In the second case, it is not equal. Third one, it is not equal. D is a none only now. Which option is correct means everybody can say very easily now. Option A is correct only now. Why it is correct? IC1 equal to IC2 equal to IC3 only. So, maybe chances. Maybe chances, no, that only chance only possible, 1.97 possible. But some students will say, sir, this current is not correct. What now? That current may come different, is it not now? Yes, maybe chance. In case 1.97, I am not getting for the IC1, you think it's none only possible then. Those two currents are same, but that may not be 1.97 also. That's why that initially we need to find what is IC1 value. After, if you are getting 1.97, this option is correct. Different value you got means none only correct now. These two will not be same. These two will not be correct only now. Now I say the question I can do like this now. These 2 milliamperes divided as a IC1 plus IX, I will write 2 milliamperes of current is divided here. How it is divided? IC1 plus IX I can write. IC1 plus IX. What is IX I ask? IX equal to IB1 plus IB2 plus IB3. But IB2 equal to IB1, IB3 equal to IB1, which 3 IB1 I can write. This I can write as a 3 IB1. Equal values of current is passing. So I can write 2 into 10 power minus 3 is equal to IC1 plus IX is nothing but 3 IB1 I can write. 3 IB1 I can write. What is IC1? Everybody knows. IC1 is nothing but beta times of IB1. You know very well. 2 into 10 power minus 3 is equal to IC1 is nothing but beta times of what? IB1 I can write. Otherwise, in terms of IC1 we can put Y. In terms of IC1 we can put, because IC1 only required. Because collector current I want to find. This IC1 I will put 3 IB1 I can write, IC1 by beta I can write. IB1 equal to IC1 by beta. And IC1 I want to measure at first. 2 into 10 power minus 3, I want to take IC1 in common. IC1 is taken common. Then I will get 1 plus 3 by beta I can get here now. 3 by beta. There you can substitute the values to measure IC1. So IC1 is equal to 2 into 10 power minus 3 divided by 1 plus 3 by beta I can write. So I can get IC1 is nothing but 2 into 10 power minus 3 divided by 2 into 10 power minus 3 divided by 1 plus 3 by beta. Beta we got as a what? Beta is given 250. 250 it is given. Use calculator and please tell me what is the value of IC1. Anybody can give its value? Use calculator and give what is IC1 here. What IC1 you are getting? Mostly it comes 1.97 milliamperes it comes. 1.97 milliamperes it came. That much current is possible. Just now I explained IC1 and IC2 and IC3 are equal. It is asking Q1, Q2 values only. So IC1, IC2 equal to 1.97 milliamperes only. So finally, which option is correct here? Which option is correct? Option A is correct here now. We can say, sorry, option A is correct in this particular problem. I can put this is correct answer. 1.97 milliamperes, 1.97 milliamperes. Two transistors can develop the same current. This is one of the good problem. Followed? If there is any doubt, you can arise. I am ready to clarify your doubts. Any student having any doubt regarding this problem? Any doubts? Akansha Sharma, can you tell, did you understand or not this question? Followed or not followed? Good evening, sir. Good evening. Good evening. The loud diaries or something is given. Yes, anyhow, good evening. Yes, I will give the next, I will give you one more question. Yes, anybody can do this question without my help. I want to wait for some time. You please start doing this question. A problem is given like this. Find the required value. Sometimes asking in the gate this type of model circuits. This circuit is nothing but voltage regulator. It is also voltage regulator. Regulation is achieved by using the what now? The supply voltage is more. Only with a Zener diode we cannot regulate. You know very well. Why Zener diode is used means to regulation of the output voltage only now, to get the constant output voltage. The supply voltage is the what now, more you think it's so. What they will do, 2 Zeners they will use generally. Still higher potential you are connecting, you think it's so. At the time 2 Zeners will what now, will not give the required constant output voltage. At the time they are going to use these networks only now. Transistors with Zener they will use. Transistors with Zener. The supply voltage more, regulation is achieved by these networks only now. Understand? Yes, can you find what V0 we can get from this? What V0 we can get? Anybody? Anybody can do this question? Yes, I will do this question. You please watch. You will get idea. It's a very good problem. In the series voltage regulator circuit shown, this is called as a series regulator circuit. Shown below, VBE 0.7 voltage, base to emitter voltage is given 0.7. This voltage is a 0.7 voltage, even this voltage also 0.7 base to emitter voltage given in the problem. VZ is nothing but 8.3 voltage, Zener voltage is given 8.3, this voltage is given. Breakdown voltage of Zener is given 8.3 voltage. This voltage is 8.3 voltage only. The output voltage V0 will be, is asking to find what is this V0. V0 value required. How we can determine this V0? It's a very simple way. We can tackle this question. I will explain, please watch. If this voltage is V0, even this node voltage also same V0. Even this node voltage also same V0 only. It won't be deferred. It won't be deferred. This voltage also same V0 I can say. This is a V0 value. What about this voltage? Anybody can say? What this node voltage is possible in this circuit? The students may ask a question, sir, why we need to calculate that node voltage, sir? If I know this node voltage, I can apply voltage divider formula here. Voltage division formula I can apply. But the students may ask one more doubt also. Sir, how can you apply voltage division formula here now? The current passing through the resistors R1 and R2 are same. If it is a R1 here, for example, the resistor is nothing but the R2 value. If current passing through R1 and R2 are same, then only we can apply the voltage division formula. But in this case, some current is diverting across these sides are. Some current may divert this side. Then how can you say voltage division formula is applicable here now? So this current is a not high current, very less current is going to flow now. But this total network you watch now, base current, this current, whatever the current it goes, maybe the base current of the transistor side only will go. Base side it is going to divert the current only now. The current passing through the base side is a very less current is possible. That current is what now? Very less means microamperes of the current is going to flow only now. That current can be neglected because, sir, I will not neglect. How can I neglect, sir, now? Subject is a analog circuits. analog circuit, what now, can give only approximate value of current or voltage or power or whatever it may be. Whatever the parameters you are calculating in the analog circuit is a approximate values only. They are not exact values only. How can you say it is a approximate values? Or means very simple. These are nothing but what but these are the elements are not. These are the elements we are using. What elements? Transistor and Gina diode. These are all the elements we are using here now. Those elements cannot have the linear characteristics exactly. Non-linear characteristics only. If they are with a non-linear characteristics, we cannot use directly. We cannot apply Ohm's law directly here now. Ohm's law is not applicable now. But here we are making an assumption. It is working in the linear mode only now. Linear we are assuming now. By assuming they are all working in the linear mode, we are doing the calculation work only. That is why answer also available. Approximate only, not exact values possible. That is why the current which is diverting this side is very, very small, base side. At the time, the current which passes this side and this side is approximately same only, approximately same. Based upon that concept only, we are going to do this work only now. Now, please watch. I wish to find this node voltage at first. That voltage I want to denote by symbol Vx. Vx. How I can find this Vx? How I can find this Vx? The Vx is nothing but, I can write Vx is nothing but voltage across this. I will apply KVL only now. I want to apply the KVL in this path. But even you have taken this side path, no problem. This voltage, these two are in parallel, same voltage you can have. The same voltage we can have. I say, even you are going in this path, even you are going in this path, it comes voltage same only now. It won't be affected only now. I am going this side. Vx equal to voltage across Z0, 8.3 voltage here. Voltage across Z0 is nothing but the 8.3 voltage. Plus, when I go this side, VBE is nothing but 0.7 voltage. Finally, its value is nothing but the 9 voltage, I can say. I am getting this node voltage is nothing but 9 voltage. Now, I wish to apply voltage division formula. Vx I want to calculate. Vx equal to, I can get V0 into R2 by R1 plus R2, you can write. R1 plus R2 is acceptable. Vx is nothing but, we got 9 voltage here now. V0 I want to calculate. R2 is nothing but 30k, kilo cancel. 30k, this is 20k. 30 plus 20, 50 I can write. 50 possible. Here 0, this 0 cancel, and 3 times I can cancel. And finally, V0 equal to what is possible? 3 5s, 15 voltage is possible. Constant output of 15 voltage is maintained by this network. Even if you are giving the 25 voltage, this regulator can give output voltage of 15 voltages only now. Constant. Even the fluctuation of the input voltage is made, this regulator can give constant output of 15 voltage only. That work is done in this particular problem. I hope you follow. Followed or not? Please respond. Did you understand or not? If there is any doubt, you can arise your doubts. I am ready to clarify your doubts. The 15 volt is exactly correct. I wish to give one more question in your hand. You please try this. I wish to give one more question here now. This is one more problem. You start doing this question. You start doing this question. Start doing this question. It's a very good problem. Can you try this? Anybody can try this question? But I want answer. I am expecting answer from your side. What is given problem? Sorry, this is a EDC given analog only now. This we can put analog. Analog question. Yes. Anybody can do this question without my help? Assuming that the diodes in the circuit of figure are non-ideal. What it says? In the given network, the diodes are non-ideal. It is given clearly. They are not ideal, non-ideal given. Non-ideal, these diodes. The value of current I2 is asking to find current I2, how much here? How much I2 passes through the network? That is the question here given. How we can do this now? I said already here the number of diodes are given, means what assumption you have to make initially? Both diodes are on. You make an assumption. There is the assumption only now. Initially we should make an assumption only now. The both diodes are working means what happens now? Drop across, but I cannot put directly. The both diodes are working. At the time the diode is a short circuited, not allowed. It is not an ideal diode, non-ideal diode. Non-ideal diode means each diode can have a drop of 0.7 voltage given clearly. Given or not given? Not given. Not given means 0.7, no doubt. Because we need to assume those two diodes are made up of silicon only. Sir, why I should not put germanium? You will get it out. Practically we are using silicon more. That's why silicon you have to assume now. This is 0.7 voltage. Its voltage drop is 0.7. You know very well it is a p-type material, it is a n-type material. P indicates plus, line indicates n-type material, negative sign is must. This is a p-type, n-type, plus this side minus this side positive. This current I want to denote by symbol I. This voltage is given 5 voltage, no doubt, they are only given 5 voltage. This is a 10 kilo ohm, it is given, no doubt, 10 kilo ohm given. This is a 5 kilo ohms, it is given. Is asking to measure this current I2. This current is I1 is given. But I think you know very well, this node voltage, you know, that node voltage. What voltage is possible? Same voltage across diode is this voltage one. Okay, for the time being, don't touch that node. How to measure this current I2 means just apply the KVL in this path. Just apply the KVL in this path. If you are applying the KVL in this path, I can measure I2 directly. Directly you can measure. If I apply the KVL, how the equation can be formed? 0 voltage ground connection, this side 0 equal to, I can write from the ground I started. When I go this side, minus 0.7 volts here, minus 0.7, polarity I gave it, minus 0.7. When I go this side, plus 0.7 voltage drop here, 0.7 drop. When I go this side, a resistor is there now, 5 kilo ohm, 5 into 10 power 3 into what current is passing? I2. My aim is to find this I2 only. Minus 5 voltage. This voltage is given minus 5. This is given minus 5. Once again, you please watch. I am writing somewhat big. Minus 5 voltage. This one given. This is given minus 5. So I can write this is minus 5. Now, can you find what is I2 here? I can cancel this 0.7, 0.7. The I2 I can get directly, current passing through diode D2. I2 is nothing but 5 by 5 into 10 power 3. It becomes 1 milliampere of current only. That current is nothing but 1 milliampere of current only. Can I take directly this, the required current here is I2 only. Is asking to find I2 here now. Is asking to find I2 value. This current is I2 is asking to find. If he is asking to find I2, can I put directly 1 milliampere? No, I cannot put directly. I2 is nothing but the 1 milliamperes. This, when I got this I2 1 milliampere, I made an assumption D1 is on, D2 is on, assumption I made. Now we need to check again, current through the D1 is possible or not. Current across D1 also you have to find, that is a I1 value also you have to determine. If I1 is a positive value and I2 also you got the positive, you think it's so. Anyhow I2 we got positive, so D2 is on, point is correct. D2 is on only. Why sir? I2 I got the positive value. So D2 is on state is correct. Because we made an assumption it is on state, it is on only. But I made an assumption D1 also on. But D1 is on or not, we need to check. Sir, how I can check? By finding I1. If I got I1 as a positive value, we can say this diode also on. Then I2 can be taken 1 milliampere only. In case, catch one more point. In case I got I1 is a negative value. If I1 equal to negative value means what we can say? Diode D1 is off only. It is not on state. Our assumption is wrong, we can say. Then I2 is not correct. I2 is not correct because both are not on only now. So we can check first of all I1 is a positive or negative. We can check at first. Then after we can see what to do. Understand now? Yes, I will get now. But in this case, I1 how I can get this? I equal to I1 plus I2 only. Then I1 is nothing but I minus what I can write I2 only. I minus I2 I can write now. What about this I star? I means current across this 10 kilo ohms. Current across this 10 kilo ohm is said to be I. But what about how I can get the current across 10 kilo ohm means input voltage we know. If I know well about this node voltage, I can determine current I. What node voltage I can have? Voltage across this diode is nothing but the what now? This node voltage only, 0.7 voltage only I can find here now. This voltage is 0.7 voltage. Then I can find I, 5 minus 0.7 by 10 kilo ohms. I want to write here again, I is nothing but 5 minus 0.7 divided by what resistance? 10 kilo ohm here, 10K minus I2 is nothing but 1 milliampere. 1 milliampere. Finally, what I1 I can get, you check it. I1 is nothing but 5 minus 0.7, 4.3 divided by 10K, that is 1 milliamp minus 1 milliampere. Now you catch my point now, 4.3 by 10K means what I will get here now? This value is nothing but 0.43 milliamperes minus 1 milliampere. The answer will be negative value possible. I am getting the negative value, not required value. Negative value is possible here. So it is a negative value means what is the meaning? I1 I got a negative value. At the time I can come to the conclusion diode D1 is not on. It is in off state only now. We can write clearly here now. D1 is off state only. So the assumption what we made at the beginning is a wrong only. What assumption we made? Both diodes are on. I calculated I2 value, 1 milliampere. 1 milliamperes we got when both diodes are on, but both are not on here now. The condition is not satisfied. So I2 is not correct here now. Then how I can determine I2 values are? We need to say diode D1 is off. Diode D1 is off means this network I can redraw in this way. I can redraw a 5 volt supply is given here. This is 5 volt supply. There is a resistor. There is a resistor here. 10 kilo ohm here. This is 10K. Diode D1 is a open circuited only here now. Diode D1 is open circuited. Why you can open circuit, sir? Because diode is a reverse bias. I got already a negative value. D1 is off. That's why there is a open circuited one now. And D2 is on only because we got the D2, I2 is a positive value we got. One information we got, D1, D2 is on state only. So D2 I can connect with 5 kilo ohm. D2 I can connect here. D2 I can connect with some resistor with voltage only. Resistor is given here 5 kilo ohm, 5K. This supply voltage is given as a, this is a minus 5 voltage here given. This is minus 5 voltage. Understand? This is open circuited one. Now I want this current now. I2 I want. This current is I2. That means even this I or I2 is same. Current is passing this side only. Because it is an open circuit, it doesn't flow any current. Now D1 is off, D2 is on. I can apply the KVL. That means apply KVL here. Now 5 volts equal to, when I go this side, 10K into I2, series circuit only. 10K into I2 here. Plus this diode is a drop across this diode 0.7, 5K into I2 here, minus 5 volts I can get now. But I want to get what is I2, 10K and 5K, 15K into I2 is possible. 5 plus 5, 10, 10 minus 0.7, 10 minus 0.7 possible. That equal to 9.3. 10 minus 0.3, 9.3 is possible here now. I want to find what is I2. I2 is nothing but 9.3 by 15K. Use calculator and give me the value of I2. Anybody can text the solution of this? What I2 you are getting? Any student can give I2 value? 0.62 milliamperes it comes. 0.62 milliamperes approximately I am giving now. If any more digits are there, means to put it, no problem. That much amount of current is passing in this network. Finally, D1 is off and D2 is on. That is the solution. Followed? Anybody having any doubt? If there is any doubt in this problem, they can arise. I am ready to resolve the doubt. In this particular problem, do you have any doubt? If it is so, you message. I am ready to clarify. Yes, I want to give one more question in your hand. You please try this question without my help. Start doing this. This is a sine waveform. This sinusoidal waveform. Yes, you find. It's a good question, repeated questions in the gate, but it's a very simple question, but asking repeatedly these model questions. Start doing this question. You can start doing this question. What is asking in the problem? Find steady state voltage V0 when diodes are ideal, not IL, ideal. This is ideal. When diodes are ideal, you find steady state voltage V0. Is asking to find V0 value. V0 is nothing but potential between these 2 points only. Potential difference between these 2 points, that is a V naught value. How many number of diodes are given? 1, 2, 3, 4 diodes are given. How many number of capacitors? 4 capacitors are given. Supply voltage is given, AC supply. That is nothing but 8 sin omega t is given there. 8 sin omega t. Anybody can say what is the name of this network? What is the name of this network? Anybody? It is a clamping circuit. It is a clamping circuit only. The clamping circuit can act as a what? Voltage doubler or a voltage tripler. Like that, any what no level of the voltage you can get one now. It can rise up the voltage, output voltage only now. By connecting the number of stages of like this, the output voltage you can increase more and more and more also. Understand now. Anyhow, for this given circuit, how to determine V naught value? That's my question. In the clamping circuit, one simple, because I am not going to derive everything now. If I explain the each and every one means it takes a lot of time only. That's why here directly I will you easily can understand. Whenever the one capacitor, one diode is given at the beginning, you think it's so. First of polarity very important now. I have forgotten to give the polarity. How the polarity is given for this capacitor, the supply is given this side, you go this side. You give always this a plus minus, you give plus minus. When you go this side again, plus minus you give plus minus, polarity like that only. And when you go this side again, diode goes this side, this is a plus and minus. When you go this side, it gives plus and minus polarity and moves. Like that polarity of the capacitors are made. And because of the given supply, steady state voltage is going to develop across the capacitor. Steady state voltage. What voltage it can develop? In any clamping circuit, initially you can have here the maximum voltage only. Maximum voltage. Next capacitor can give always 2 Vm. Next capacitor can give again 2 Vm only. Even next capacitor also same 2 Vm only possible. Whichever the capacitor you have taken, you will find like this only now. The first capacitor only Vm. All the rest of capacitors can give the 2 Vm only. Because of why the only Vm is possible means here the initially we are giving one positive pulse or something. That positive one single pulse is given means only Vm only possible. That Vm can give the what maximum voltage a Vm only possible. When the pulse is given slowly rises and reaches to maximum value, that maximum voltage it can develop. Next it comes the negative pulse only now. Initially positive, next you are giving the positive. Peak to peak voltage is available in rest of capacitors. Peak to peak voltage means plus Vm minus Vm, Vm minus of minus plus minus of minus Vm, 2 Vm you will get now. There is a 2 Vm, 2 Vm, 2 Vm only. Voltage across the capacitor will not cross more than 2 Vms are. One is a 2 Vm means next 3 Vm, next 4 Vms are impossible. Why? Because peak to peak voltage is a 2 Vm only now. So maximum voltage across the capacitor is peak to peak voltage only now. It never crosses. If it crosses more than the 2 Vm means what is the meaning? Diode also acting as a amplifier only there now. More than the peak to voltage means it is acting as an amplifier only, but it is not an amplifier. Diode cannot act as an amplifier. It doesn't give more than 2 Vm only. That's why 2 Vm, 2 Vm, 2 Vm only possible. Now directly you can calculate V naught value. By applying the KVL from this point to this point, just apply the KVL from this point to this point. You are going to get the V naught value. So I can say V naught is nothing but I want to get V naught. Directly you can get the GATE exam. V naught is nothing but when I go this side plus 2 Vm here, when I apply the KVL plus 2 Vm I will get. Plus 2 Vm I can get. That's all, no more voltage. 2 Vm plus 2 Vm is nothing but the 4 Vm is possible. But in a problem, maximum voltage is given. What is the maximum voltage? 8 voltage is given here now. 8 voltage is going to be the maximum voltage. This is the maximum voltage. Maximum voltage is 8 voltage only. Yes, you substitute here now. If I substituted this Vm, I will get 4 into 8. 32 voltage is possible. Finally, here the answer is taken as a 32 voltage. Option D is correct in this particular problem. I can put this option is correct. Option D is correct only. 32 voltage. Such a way we can tackle this question. Did you understand or not? Any students are having any doubt regarding this question? Sir, how the 2 Vm is means we have to apply again. Process we have to, some process is there, it takes a lot of time only now, understand. Directly you can substitute these values and you can calculate in the GATE exam, understand. I want to give one more question, you please try. Yes, this is one more GATE question. One more question I say, one more problem I am giving. Anybody can do? Any student can do this question? Anybody? But I want to give some time. You please try. Any student can do. What is given? For the given circuit, assume op amp is ideal. Operational amplifier is ideal, he says. The current I is equal to 0, where R is dash kilo ohms. What it says, that point you watch. Current I is 0. This current is given 0 amperes only. This current is 0 amperes is given. I equal to 0 amperes. What is this R value? Is asking to find. What is this R value? Current I equal to 0. You find out what is R. That is the given question. Op amp is ideal only here now. You watch how I will do this question. The current is 0 amperes. Can you find drop across 3K here? We don't find any drop across 3 kilo ohms because current is 0, voltage drop also 0 1. At the time I can get this node voltage as 1 voltage only, same 1 voltage I can get. So there is no drop across 3K, 0 amperes given strictly in the problem only. But these are all nothing but the inverting operational amplifier. This is one of the inverting operational amplifier. This is one more, but no, inverting operational amplifier. From this inverting operational amplifier, I wish to find what is this node voltage. What is this node voltage? This and this and these are the same V naught only. These are all nothing but V naught values. If I know this node voltage, I can determine V naught. If I got the V naught, I can determine R value. How possible, you watch. What is this voltage? I want to take it as a V1 for example. I give the name of V1 here now. How to get that V1? You please watch. From the non-inverting operational amplifier, you know very well. V1 is nothing but output of this op amp I want minus R2 by R1 into input voltage, you know very well. R2 means minus 3K by 3K into this input voltage 1 voltage only. That becomes minus 1 voltage I will get. I am getting this V1 as a minus 1 voltage. Clearly you watch. This voltage is given as a minus 1 voltage. I am getting minus 1 voltage. Now can you say what V naught I can get here now? I will get V naught like that. Again I want to apply inverting op amp. In the inverting operational amplifier, what output is available? V naught I can get gain of this output voltage I can get from this feedback network, from the inverting, minus R2 by R1 into V1 minus R2 is nothing but 12K, R1 is nothing but 3K multiply by minus 1. So K cancel, 3/4 I can cancel here now. Minus minus plus 4 I am getting here now. Minus minus plus 3, correct or wrong? 12, this is a 12 only you got, is it not? 12 means I am cancelling 3, 4, 12 cancel here now. I am getting the 4 times cancel now. So plus 4 voltage I am getting here now. So what is the point of calculating that 4 voltage means by using the voltage, by using the nodal analysis I can find the R value. By using nodal means how I will apply, please watch here now again. At this node, this current plus this current equal to 0. Anyhow, we know very well it doesn't flow any current. Current is 0 only this side. This current plus this current equal to 0. From that point I can get. You know very well this node voltage. Same 0 voltage I can find. V plus and V minus are same. So this current is nothing but 1 minus V naught. I will take like this now. 1 minus V naught. 1 minus V naught, this current 1 minus V naught by R I can get, plus this current is nothing but 1 minus 0 by 3K, 1 minus 0 by 3K, summation of all these currents equal to 0, you know very well. V naught we got 4, 1 minus 4 divided by R plus 1 by 3K, no doubt, this is equal to 0. 1 minus 4 minus 3 by R plus 1 by 3K, that equal to 0. So 3 by R equal to what? 1 by 3K. So finally R equal to what I can get? 9K, 9 kilo ohms is mostly possible. R equal to 9 kilo ohms possible from this problem. Like that we can tackle this question. That is the answer for this question. Followed? There is any doubt you can ask. Yes, 9 kilo ohms, exactly getting answer. This is the way you can apply to get answer for this R. Yes, I want to give one more question in your hand. You please try it. This is one more question. Anybody can do this question? Anybody can do this question without my help. From the transistors, this is the question was given from the transistor. For the circuit shown in figure beta equal to 100, the current gain of the transistor is given 100. IC is nothing but 0.25 milliamperes and VCE 3 voltage. The value of RC equal to how much is asking. But the given values you watch IC and VCE and also what is given IC and VCE values are given. These values are DC values or AC values. DC only now. Under DC analysis, these values are given. VCE and IC are denoted. These what now? Letters are denoted for the DC analysis only. That means under DC analysis only we need to calculate only now. Under DC analysis, these parameters I can use. So under DC analysis, certain conditions are there. Wherever the AC input is given, that must be shorted. Under DC analysis, wherever AC source is given, you short circuit. Wherever capacitor is given, that must be open circuited. And rest of circuit you can draw clearly. You will get the value. I am drawing this circuit, you please watch how I will draw this. What I want to do, under DC and a solution I want to get now. I want to apply DC analysis. Under DC analysis, wherever the capacitor is given, that must be open circuited. AC voltage source must be shorted. AC voltage source is short circuited. These conditions very important. Now we can redraw the network. What network is given? This is removed. Capacitor is a open, this is a short, this totally we can remove. I can have one transistor. I will connect a transistor here. This transistor is connected with RC with 5 volts. RC with 5 volts. Here connected with 5 volts. And also this RS is given 100 ohms here now. RS is given 100 ohms. This is given 100 ohms only now. And also here given RE is connected here now. Capacitor must be open. RE with -5. RE and -5. This voltage is given -5 volts. Yes, that's given -5 volts. -5. 150K here connected now. 50K is connected this side. This is 50K resistor is connected here now. That's connected with 50K only now. Understand now. Next 50K RC and V0. V0 from here only now. I want to get is asked anyhow V0 is taken, but not required any V0. They were required only RC only now. RC, sorry. RC required, RE here given. In the problem, certain values are given. What values are given? Beta is 100 here. Beta is given 100 here. IC also given. Collector current is given in the problem. What collector current is given here now? 0.25 milliamperes. 0.25 milliamperes of IC is passing here now. And also given here now VCE 3 voltage is given. I can put VCE 3 voltage is given. VCE 3 voltage is given. VCE is given 3 voltage. RC is required. Is asking to find RC value. What is RC? What is RC? That is the given problem. This is the given problem. But directly I cannot measure RC value. Initially we need to calculate RE. Once I know the RE value, I can determine RC value. Sir, why required RE? Doubt is common. You know very well this current is given in the problem. IC is given 0.25 milliamperes. 0.25 milliamperes. Correct or wrong? Once again, 0.25 milliamperes only given. Then collector to emitter voltage is given 3 voltage. From here to here it is given 3 voltage here. If I applied, catch my point. If I applied KVL from top to bottom, I can determine RC value here. But to determine the RC value, KVL we want to apply, then we should know RE value. Without knowing RE value, I cannot get answer now. Sir, how I can get these REs are? You please watch. You can watch now. Here, what I did, this current is nothing but the base current, you know very well. This current is nothing but the emitter current, you know very well. By applying the KVL in this path, I can determine. By applying the KVL, I can get answer only now. Applying KVL means IE can also be written as a what? 1 plus beta times of IB. We know very well. Emitter current equal to 1 plus beta times of IB. If I applied the KVL, drop across this 50K is nothing but 50K into IB here plus base to emitter voltage is nothing but 0.7 voltage, we know very well. And these two are in series, RE plus RS, RE plus 100 into what current? 1 plus beta times of IB. Beta is nothing but, what is beta given here now? In a problem it is given, beta is 100, 101, approximately 100 also no problem. 1 plus 100, approximately 100 even written, no problem. Into IB. Into IB only. And when you go down, minus 5 voltage we got here now. What's my point? Catch my point. This is 0 equal to supply voltage 0 equal to 50K into IB, 0.7, 100 plus RE into 101 IB minus 5 you got here now. Then you find what is RB. Well, IB is required here now. IC we know very well. Base current you can determine directly. Base current is nothing but, directly you can write now. IB is nothing but IC by beta you can write directly. IB is nothing but IC by beta you can write directly. This I can write 0 equal to 50K into IB. IB is nothing but IC by beta. IC is nothing but 0.25 milli divided by beta is nothing but 100 here, plus 0.7 plus RE I want to find plus 100 here into what I can get 101 into IB is nothing but IC by beta 0.25 into 10 power minus 3 divided by beta is nothing but the 100 only now. Wherever IB is given, there I have taken IC by beta only here now. Then you find what is RE here. You find what is emitter resistance. Anybody can calculate what is RE here? Once you know RE, you can find RC value. This value will be, I'll give RC value directly. Yes, emitter resistance it comes 16.43 kilo ohms possible. After getting RE, you apply the KVL from top to bottom. 5 volts equal to, I can write supply voltage equal to 0.25 milli 10 power minus 3, 0.25 milli into RC, applied KVL, plus VCE is nothing but the 3 voltage here, drop across this 100 plus, RS is 100 plus, RE is nothing but 16.43 kilo into what? IE, 1 plus beta into IB. 1 plus beta means 101 into IB is nothing but IC by beta. IB is nothing but IC by beta. IC 0.25 milli by beta. That is a 1 plus beta into IB also. This into IB minus 5. Minus 5 only. Just a KVL I applied from top to bottom. So 5 equal to RC 0.25 into 10 power minus 3 into RC. This voltage is a 3 voltage. The voltage drop 100 plus RE. 100 plus RE is nothing but this into what current here now? IE 1 plus beta 101. IB is nothing but IC by beta 0.25 into 10 power minus 3. If you want beta also, you can put directly here now. Beta equal to what is possible here now? This value will be 100 only here now. This value is 100. When you go down minus 5, then you find what is RC here. Then find what is RC. If you are using calculator, RC value will be 11.3 kilo ohms. 11.3 kilo ohms it comes. That much value is possible. Such a way we can tackle this question. I think you followed. Did you understand? If anybody having any doubts, they can arise their doubts. Yes, I want to give one more question in your hand. Yes. You please try these questions. Sometimes asking these model questions also the gauge. Please start doing this question. Please try this question also. But I want to wait for some time. Please complete. what is given the problem? In the circuit shown, assume that the op amp is ideal. This operational amplifier is ideal, it is given. If the gain V0 by Vn is minus 12, that means the gain is given V0 by Vn is nothing but minus 12. Gain is given directly. The value of R equal to how much? Is asking to find R value. Anybody? Anybody can do this question. Start doing this question. What is the value of R? I want value of R here. I want value of R. How we can do this R means, please watch. This is the op amp is operational amplifier is ideal. So in that case, V plus and V minus are same. V plus and V minus same. V plus is with 0 voltage, this voltage also same 0 voltage, no doubt. Same 0 voltage. I got this node voltage. This node voltage I want to denote by symbol V, for example, or by V1. We can assume, no problem. V1 is required. That's given a name V1 only here now. So initially we can try for what is V1. Without knowing the V1, I cannot find R. By using the nodal only, I can get V1. If you want to get nodal analysis applicable, this current plus this current equal to 0, I can write. By using the nodal, I can form nodal equation like this. This current 0 minus V1, I can write like this, 0 minus V1. 0 minus V in divided by how much? 10K, 10 kilo ohm. This current is nothing but 0 minus V1 plus 0 minus V1 by how much? 10K. That value is at 10K. That equal to 0. 0 minus V in by 10K, 0 minus V1 by 10K is possible. I can cancel 10K, 10K. Then I can measure what is V1. What I got? Minus V in here. Minus V1 equal to 0. Then I can write V1 is nothing but minus V in I am getting. Yes, I got V1. V1 I got in terms of V in 1. But in order to, but I want to find V0 again now. V0 also I want to get in terms of Vi, V in. V0 in terms of V in means V0 by V in, value given minus 12. V0 by V1 in terms of R you will get. That R you can calculate very easily now. I say after getting V1, you try to apply nodal analysis again here now. This node I selected. This current plus this current plus this current equal to 0 as per nodal. So this current is nothing but V1 minus 0 by 10K. V1 is nothing but minus V in. Minus V in I can write. This is minus V in. Minus V in minus 0 by how much? 10K, this value. Plus V1 by R, this side current. V1 by R. V1 is nothing but minus V in by R. This current V in by R. What about this current? V1 equal to minus V in. Minus V in minus V0 by how much? 10K I can write. By 10K. That equal to 0, I can put directly. Then V0 by V in, we know very well. Divide numerator and denominator, but divide by what now? V in totally. I want to divide by V in. Divide by V in. If I divided by V in minus 1 by 10K, I can get. Divided by V in means minus 1 by R I will get. Divided by V in, this is a minus 1, I can get here now. V naught by V in I will get. V naught by V in. V naught by V in divided by 10K, that equal to 0. Then I can write what is V naught by V in. V naught by V in is nothing but minus 12 is given. You can get answer now. Minus 1 by 10K here, minus 1 by R here, plus minus 1 V naught by V in minus 12 minus plus 12 divided by 10K I can put now. This is equal to 0 only. That equal to 0. You measure what is R now. What is R? You calculate. What is the value of R? You can find that R value comes as, I will give that value. 1 kilo ohm it comes. R equal to 1 kilo ohm is possible. By using the calculator, you can get what is R there. That way you can get answer. I hope you follow. One more question is there now. I want to give. That is going to be the last question now. I want to give last question for today class. This is the last problem. Any more are there? No more. This is the last question only. Can you complete this last question without my help? I will wait. You please complete this question. You complete this question. Anybody? You complete this question. Yes, what is given in this question? An amplifier has mid-frequency gain A naught equal to 150. A naught or A, no problem. There is a 150. An upper cutoff frequency FH is given 50 kilohertz. 50 kilohertz. And lower cutoff frequency FL equal to 40 hertz is given. For a feedback factor beta equal to 0.1. The upper cutoff frequency with a negative feedback is 4 options given. Upper cutoff frequency after feedback only required. What feedback? Negative feedback only. Anybody can do this question? Anybody? Anybody can do? Here given in this problem, A naught is given, A naught or A, no problem. That is a 150 is given here now. This is given 150. 150 it is given. FH is the upper cutoff frequency. Okay, I'll write no problem. Even they're given, I will write on standing purpose. 50 kilohertz, no doubt. And lower cutoff frequency, FL also given. FL is nothing but 40 hertz. Beta also given in the problem. This is a 0.1, no doubt. Upper cutoff frequency after feedback is asking F, H, F. After feedback, you find the upper cutoff frequency. After feedback only. After negative feedback only required. But we need to create the formula. Without creating the formula, we can't do only now. You know very well one point. What point we know, sir? Suppose you have drawn gain versus frequency diagram. Gain versus frequency diagram you have taken for example. Gain versus frequency diagram in the amplifier, if it is taken, it comes like this mostly. It goes like this one. It goes like this. This will go down. This we are going to call it as a FL low cutoff frequency. At 3 decibel frequency it comes now. FH it comes like this. High cutoff frequency. FL and FH. So these FL and FH values are given before feedback. This diagram. Here the what feedback is given here in the problem you watch. What feedback is given here now? This is given with a negative feedback is given. Negative feedback is given. Due to negative feedback, gain is going to increase or decrease. That point you need to understand. Because of the negative feedback, what is going to happen is this gain will be reduced. Gain is going to reduce. This gain is reducing. Whenever the gain is reducing, this FL and FH will be changing only. FL will go, because the gain is reduced means this will go, FL will go this side, FH will go this side. That means FL becomes FLH after feedback. Low cutoff frequency after feedback. After feedback, after feedback we can write. After feedback, FLF. But when the gain is reducing, this frequency will increase. FHF it comes. FHF after feedback only. But in this case, what is a, but he is asking high upper cutoff frequency only. FHF required. FHF is required. FHF is increasing or decreasing here now. FLF means reduced only, decreased only. FL is here, less than FL it comes. FHF means increases only. Increases means multiply by 1 plus A beta. Decreases means you must divide by 1 plus A beta. That means FHF means 1 plus A beta times, A means A naught beta times of FH we can write into FH. Into FH. 1 plus A beta will be multiplied with FH only. If it is increasing, because the product can increase only now. FLF means what you can write now? FL by 1 plus A beta, reducing. FL by 1 plus A beta you can write now. There you can substitute values, you will get FHF directly. 1 plus A naught is given in the problem 150. 150 it is given. And beta is given as a 0.1. And FH is nothing but how much? 50 kilohertz only. 50 kilohertz. Use calculator, you will get FHF directly. What frequency is possible? Anybody can use calculator to give its value? This value is like that it comes, I will give. Just a minute, I will give. That value comes as yes, I don't get the value I think now. Use calculator, you find whatever the value here now. And what value it comes to check it now. You calculate, use the calculator and find its value. Whatever the value it comes, you calculate. And which option is correct to check it only now. This way you can determine high cutoff frequency. Yes, these are the problems mostly possible in today session only now. But in before that, just you please listen the some information, good information regarding the IMS Gate Academy futures and everything you need to understand. Very initially I explained. The Telegram, the students can join in this IMS Gate Academy Telegram channel. But what is the advantage of joining in this Telegram channel? It is a free only now. Anybody can join. Any student can join. The schedules of the free YT YouTube lectures are given by the number of faculties, the different branches only now. The students wants to know the dates and timings and everything you think it's so. That will be given in the Telegram channel only. If you join in the Telegram, you can understand when you can have the what now schedules. You can understand lecture PDFs possible. So far I explained analog circuits problems. This PDF file will be what now uploaded in this Telegram channel. The students can once again they can watch and they can practice the questions also now. Important updates related to the seminars and webinars will be given. PSU and other government job notifications will be given. Expert session on important topics possible. Daily quiz and many more. The number of faculties are going to post on each and every day questions, quiz questions only now. The students can tackle those questions now. If they are getting answer, very good, they can give now. If they are unable to get answer, solution will be given by the what now faculties later on with explanation now. Then they can understand only now. These are the advantages possible if you join in this Telegram channel. Next one. The students who wants to take the admission in GATE 2025 and 26, they can go through it. The live online program is this only. Program features are 800 plus hours of the live classes with the live interactions possible here now. But in the when the students gets admission in IMS GATE Academy, they will get the theory book, exercise books, and 30 plus years of GATE question banks with video solution. Not required any other textbooks. The every information will be given in these 3 books. Theory, whatever the concepts are required will be given. The exercise books, level 1, level 2, level 3, like that what not different problems will be given with solutions. You can practice and you can check your answer also now. And 30 plus years of the GATE questions bank with the video solutions of certain questions given here now. Not certain, many questions only given here now. That's why students can practice all the questions and solutions also given. If they don't understand, they can watch the what now video solution also. 12 personalized one-to-one mentorship sessions possible now. In this mentorship session, the faculty is going to have the contact with you and he will have the what now discussion with you and he will give what is the planning for the preparation only now. 130 plus online tests with video solutions of the mock test and many more possible. If any students wants to take the admission in IMS GATE Academy, here given the phone number is given here now. You can make a call and get the information. Understand now. This is the today's session. I hope everybody enjoyed with the class. Thank you all.